Welcome to the Mycronic booth here at IPC Apex Expo. I'm delighted to be joined by Robert Halliday, who's the head of R&D, and Kevin Clue, who's the director of sales. Okay, pleased to meet you, gentlemen. Thank you for joining me.
Thank you for having us.
Okay, so I want to start off, if I may, Kevin. I mean, the whole Mycronic process platform, if you like, has been evolving over the years. So what are the driving forces behind this?
Yeah, I think that Mycronic has always been very well known for our abilities to accommodate high flexibility, high versatility in the circuit board assembly arena. Mm-hmm. And we still continue and will continue that as our focus point. But I think one of the leading contributors to how the portfolio has evolved is our ability now to support the full line solution.
Okay.
I think that's a really important point for our customers as they're looking to manage their supply chain. So we're able to support the full line all the way from paste deposition, either with screen printing or jet printing technology, through to inspection, SPI and AOI, and pick and place, as you know that, with material handling. And then on top of that, it's the full software solution to pull it all together. And I think that's really how the product line has evolved.
Right, okay. Well, I mean, you did launch two major platforms at Productronica. I mean, there was the pick and place platform, which is behind us, a MyPro A40. Yep. And then there was also this closed loop stencil system. So you actually brought out a stencil printer. Which,
I know. Who'd have thunk it?
Who'd have thought that?
Yeah.
I mean,
no, exactly.
But then it is a closed loop system because it was followed up by inspection and, as I recall, and a jet printer to do top up for missing paste or insufficient pastes and things like that.
Yeah.
You know, talk to us a little bit about both these systems.
Yeah, so I mean, I'll let Robert talk a little bit about the A40 platform, which is our new pick and place platform that's being launched at Apex here. But the other platform that's new to Mycronic here is our screen printer. We talked about that, you mentioned. And so you ask, why did we bring a screen printer after selling jet printers for so many years? And I think that the value proposition to our customers is the marriage of screen printing technology with jet printing technology, with SPI technology, and having a closed loop feedback system to encompass all three machines in that paste deposition process. And I think the position that we have at Mycronic is it's a unique position because we are now able to provide solution for all of those three aspects in a closed loop system. I think we're the only guys able to do that. So,
I mean, it makes a lot of sense. I mean, because there was quite a few companies out there in the field who were deliberately putting a jet printer after the screen printer, the stencil printer.
Correct.
To be able to cope with the throughput and that sort of thing. So it makes perfect sense. You've actually just improved it by bringing bringing your own in and your own inspection to that.
Yeah, and process. I think you're able to use the SPI technology to control a repair loop using the jet printer. You can use the jet printer as an additive manufacturing process to an already stencil printed board. So there's so many options and so many flexible choices that a customer can use when they're working in that paste deposition process. So it's a nice position to be in.
Really interesting. Okay, so let's turn our attention to Robert and the MyPro A40. I mean, when you look at it from the outside, it doesn't look any different from the previous model, but I believe it's completely different inside.
It is completely different inside, and it's along the same story as we had at the screen printer, because we've seen that our customers, they love our flexibility. We need to always have that, but we also seen that they have mixed boards. And when they have that, they drop a little bit in the throughput of the line.
Yes. With
the previous My 300 generation. And we wanted to help them with that. Mm-hmm. So then we decided, okay, which is the best way to do that? And the best way is to increase the component range of the high-speed head.
Right.
Okay, so before they needed to go to the single head, but now you can do boards like this. Mm-hmm. You see the range of components, and it's pretty. This is
really big.
It's really big range.
Some tall components there.
You have tall components, you have wide components, and this is how many of the boards look like at our customers, and we know our customers very well. So we've seen that. Okay, this is the range they actually need in order to keep the throughput independent on the mix of the board.
Yeah.
Mix of components on the board. So to my left here, I have the new head. So that is the heart of the machine.
Okay.
So this is like a major heart surgery, if you will, that we have replaced the old head with a new head.
Now it's still a gang pick format, is that correct?
Yes.
Yeah.
So now it picks 7, but each of them are individually controlled.
Okay.
So that improves the speed. It still consistent flexibility, and there's also many other new bells and whistles on the head, like you have vacuum check to see the component is there, and also very gentle placement force, so that we keep the integrity of all components there, and you don't make a splash of solder paste or anything like that. So there's millions and millions of things in the new head that really makes this a new machine,
right,
and not just a facelift.
Yeah, I mean, well, having a gentle placement force is important, and for some devices, but you also need some where they need a little bit more.
Yes, and we still
power devices and things like that.
Yeah, and we have the Midas still.
Yeah.
So that one can go up to 90 Newton or something, or 90 kilograms. I can't remember now. Kilograms, yeah.
Yeah.
And so we still have that on the machine because we need that for all these special components.
Okay.
And you can say our customers, they might have 1,000 components on the board. One might be special, but they still need to place it. So we didn't drop that one, so that you have the full capability. It's an all-in-one machine still. Okay. And that makes it very flexible as well.
Right. So let's get on to the really interesting news here, and that is just before Apex, you announced that you're going to be launching a deep learning-based solution.
Yes.
Tell us a bit about that. What is it?
And this is on the AOI side. And here we also know that you have to have a trade-off between the sensitivity of the inspection in order to avoid escapes. You can't have escapes.
Right, of course.
But the downside is that you get a lot of false calls. And the way this is handled in today's industry is that you have an operator looking at the pictures and saying, this is a false call, this is a false call, this is a false call. And you get a lot of false calls because you want to avoid the escapes. So now we have a deep learning system that will remove about 90% of the false calls without letting through escapes. So the operator can focus only on the real defects and not having to sit there and
well, imagine if he's sitting there having to look at all that number of false calls, which are not false.
Yes.
Then he's going to end up getting complacent, and you're going to end up getting human error creeping
into
there.
And we've seen that in the data. We look very close to the data now that we have from various customers that we collaborate with. And we see that humans are not perfect, unfortunately. And by this, the operator can focus more on the real defects and see, maybe analyze that and see what is behind that.
His ability is going to be sharper because he's looking
much
at real
sharper
defects rather than wasting his time.
And it's not a repetitive process on just letting things through.
Right.
And it's a very advanced system. We use a specific AI server with 2 GPUs connected to the machine, so that the data goes from the machine to that server, not to anywhere else. It's not ChatGPT or anything on the internet. It's close in the factory. So we keep the integrity of the customer's data, basically, in this point.
Okay, that's interesting. You keep it, it's all within the machine. It's not going up to a cloud or anything like that.
I know.
I mean, I think that's a great idea. I mean, it keeps learning, though. I mean, but these false calls, again, the customer sets the parameters at the beginning anyway. I mean, the customer says, well, this is where I consider it a false call, or if it's 20% off, we'll let it go, kind of thing. So, but he's taking the customer's parameters and basically applying it and learning over time. So how long does it take for the machine from initial install to get up to learn enough to
That's still out there a little bit, but because this is pretty new, so we don't have the various customers, but depending on how much data you have stored. So at some customers that we're working on right now, they have 8 years of data already stored in the machine. Then it's going to be instant. But they was
Cisco, what do you store? Store everything.
so exactly. So but from this point we have the customer still in control. So they can have the training process, and then they run it in simulation mode until they really trust it. Then they can lock it and put it into production mode.
Right.
Yeah. So that's how it works. So they will still be in control of the whole process.
Yeah. So Kevin, what does this really mean in concrete terms on the shop floor?
Well, I think we've already kind of touched on it a little bit, Trevor. Rather than an operator sitting at an AOI machine going, false call, false call, false call, false call, we're allowing the machine to take care of all of that triage, not all of it, but most of it, allowing the operator to therefore focus on truly what is a defect. Yeah. So I think the operator will become more tuned to understanding what is a true defect, but it's also going to free up a lot of time for that operator. Right. So that operator can now do a lot of other tasks. So the value proposition is quite significant. There's labor savings there, but also the ability to make sure that those that operator's skill set is tuned to really identifying a problem.
Right, okay. So just finally coming back to you, Robert, on this question of AI. I mean, what is the long-term strategy you've got for Mycronic in terms of AI integration?
The long-term, I mean, even in the short term, we want to give the customers more automation, right? Okay. So that we have some tasks that are easier to automate like that with AI. For instance, to do the feeder trimming or to do that kind of tasks, where it's very obvious you have somebody looking at the picture saying yes or no and so on, right? That's just the beginning. The long-term strategy, I think, is to avoid doing errors, to really have correlation between data from all over. It could be even from what supplier of components do you have, what tape do you have, what is the 3D picture in the jet printer. What is the entire everything, and back to, and downstream to the ICT test when you have errors, to detect anomalies and to help the customer to say, okay, how can we improve that process? So there's endless opportunities here for that part. It's all data based. Yeah.
I mean, I think honestly, you're just at the beginning of this journey.
Yes, we are. We know that.
I think it's going to have a long way to go.
Yes,
but I mean, Mycronic is going from strength to strength. We can see that with the products that you keep evolving and bringing out. So I want to thank you for sharing that with us today.
Thank you.
Thanks for having us.
Thank you.